first session automotive panel. As panelist from AISIN, Mr. Ide, from Bridgestone, Mr. Sato, Toyota Center Research, Ms. Ohba. Moderator is from Deloitte Tohmatsu Consulting, Mr. Terazono, who is the director of Deloitte Tohmatsu Consulting. Terazono-san, would you please take the podium? And thank you very much. Let me introduce myself. I represent Deloitte Tohmatsu Consulting. I'm the leader of the advanced R&D team at Deloitte Tohmatsu Consulting, and I'm also representing as the Japan lead in the quantum domain. So I have the pleasure of serving as the moderator for the automotive sector today. So for my side, from Ide-san, would you please start introducing yourself? This is Ide speaking, representing AISIN. I'm the Chief Senior Specialist at AISIN. At AISIN, utilizing quantum computing, I'm engaged in the application development. I'd like to ask for your kind cooperation and attention for today's panel discussion. Sato-san, let me introduce myself. I'm Sato, representing Bridgestone. I'm affiliated with analytical and material digital transformation research. Usually, I'm engaged in the tire material development, how to make the material development more efficient and advanced, utilizing the computational science. And I was interested in the quantum chemical computation. That is the backdrop. The reason why I was interested in quantum computing. Representing Toyota Automotive R&D, this is Tomoko Ohba. This is founded in 1960 with the stakeholders such as Toyota Motor Company, the group company, jointly the investment. What could be achieved by the quantum computing? I'm engaged in this research in the area of monozukuri, manufacturing, material development and design application. Quantum computing, I was engaged in the first principle calculation of condensed matters. So the kind of challenges that was difficult to be addressed by the classical computers, how the quantum computing could probably provide a solution, and this is the area I'm quite interested. So we'd like to start with this discussion. As was mentioned by the self-introduction, some people are interested in material informatics or material development, and there are various use cases that are contemplated by the various stakeholders in the automotive industry. The use cases in the automotive industry and the applicability or usefulness of the technology of quantum technology. So I'd like to ask each one of you to enlighten us on the engagement that you have got in the use case on the application of quantum. I'm engaged in the logistics, especially that is nice to the people and environment, reduction of the CO2. So this is Ide-san speaking. In the logistics industry, it used to develop upon the intuition, sixth sense of the human, the operators, but utilizing the quantum computing, you should rely much less on intuition to achieve the optimization of the trucking and the environmentally friendly logistics. Saguchi from my company spoke yesterday at the keynote speak. So in terms of the addressing the global environmental issues by 2050, achieving carbon neutrality and conversion to sustainable material, that is a long-term goal. This is Mr. Sato speaking. For the carbon neutrality to be achieved in the automotive, the tire, the development for the tires for the automotive application, there are diverse kinds as well as the dimensions. Kinds and nature and dimensions, there are diverse kinds of automotive tires. In order to manufacture the diverse tires, so we have to switch in between different manufacturing apparatus that is suitable for each kind of the product. How could we could optimally combine those manufacturing equipment? This is the key to the tire manufacturing. So if you consider the number of parameters associated with the production, the combination of production parameters could be more than millions, several millions. So the production planning, we have to choose the optimal combination out of the millions of the parametric combinations. So the production-related parameters, they vary from day to day. They change from day to day. That should be reflected on the production in a dynamic manner. So we have to resolve the optimization issue as quickly as possible. So that is the reason why we entertain expectation to the quantum computing, my major battleground in the tire material development. Choice of sustainable material is needed to make the tire suitable tire. What kind of chemical reactions that will take place inside the tire? So it is important to elucidate the intrinsic chemical reaction that happens inside the tire material. There could be ionic reaction, radical reactions, and ionic and radical reactions that are combined in a complex manner. In the conventional chemical quantum chemical computation, we used to assume either ionic or radical reaction one way or the other. However, with the Q-Park consortium, we should be able to analyze with the use of the quantum computing combination of ionic as well as radical the reactions. We are currently utilizing only a few atoms of analysis, but we should be able to have a more realistic model size calculation in the structural design of tires. The current method of calculation cannot be worked out in the practical time that is allocated utilizing the finite element, but utilizing the quantum computing, the quality of the product development will be greatly enhanced. So for the company, we are participating in the consortium and we are consulting with the startup companies. What kind of values could be generated in the various aspects of business areas? So we have not embarked upon specific use cases yet. We have to convince the top executives of the company to be interested in quantum computing. It will take a while for the top executives of the company, the tire company, to be interested in quantum computing. In the manufacturing industry, in monozukuri or material development, so this is the area we are exploring use case in monozukuri or manufacturing. It was indicated by Sato-san, or the tire manufacturer. Not only to the automotive industry, the quantum computing has a massive scale of the computing capability. So harnessing some such capability, optimization could be the major the use case application in the area of monozukuri manufacturing. Currently, in manufacturing, prior to the manufacturing inside the computer, the performance and functionality should be simulated inside the computer. Then we'll go ahead with the prototyping. So computer-aided engineering, CAE, is the mainstay of the current use of computing, but applying the quantum computing. So that is a quantum CAE is the buzzword that we'd like to pursue and explore into the future. The physical simulation of the performance and functionality. The basic the equation, a partial differential equation, how could we solve utilizing quantum computing the partial differential equation? So we're involved in the algorithm development, in the material development. Utilizing the classic computer, due to the cost constraints, it was very difficult to calculate the excitation conditions or dynamics calculation. This is the area where the quantum computer should be employed and should be applied. So this is the area or the potential area that we entertain expectations on.
Thank you very much. So as three panelists shared earlier, there are many potential use cases. For example, the optimization of logistics or materials development is another area of potential use cases. But at the moment, as we speak, because in my consulting practices, I engage with various companies, and we often run into this question. Are there any problems that can be solved with quantum technology alone? Or what are the definitions of such problems which can be solved by quantum alone? So that is my next question. So when there is a topic or problem, do you think that there are problems that can be solved by quantum alone, or do you need to combine quantum with other technologies? How do you feel? And in case of combinations, what kind of challenges do you see in combining quantum with other technologies? Ide-san, please. So my answer to the second part of the question, combining quantum and classical would be the best way for the time being. Let me explain why. Classical computing have existing know-how and assets. Massive amount of know-how and assets already exist, and we want to tap that. And quantum side, there are many challenges unresolved. The first one is hardware, such as superconducting or trapped ion, or cold atoms, or neutral atoms, or optic. We don't know which one is the best, and we need some time to see which technology will survive. Also, the quantum computing better handle large-scale computation, which cannot be handled by classical computing. So we have to know which are the specific calculations which best suited to a quantum computing. And in my mind, quantum machine learning could be one of those areas where quantum have advantages. Sato-san, please. Yes, thank you. So my specialty is quantum chemical computing. So let me talk in that field. Suppose that there's molecule A and molecule B, and we'd like to analyze the reaction between the two. Then we bring these two molecules closer gradually and then calculate the electronic state. So this calculation of electronic state can be switched from classical to quantum computer. This is a simple replacement and can be handled by quantum computer alone, so it can achieve actual value. However, the part of bringing molecules closer will be done by classical computers. So that means between quantum and classical computers, the data have to be transferred back and forth. It is going to be a hybrid approach, and this communication or data transfer between the quantum and classical could become a bottleneck. That is a small concern I have. What about you, Ohba-san? Once we have the fault-tolerant quantum computer, then that will be good enough to solve many problems. But at the moment, I believe that the combination with classical technology and classical computing will be the way to achieve a value. But in that case, I have also one concern. In classical world, you have a digital data, and that have to be encoded into quantum state. Can we do it successfully? And the interfacing or communication between the two worlds is another area of concern for me. Also, NISQ, noisy intermediate scale quantum. But when the size of computation increases, then even quantum computing cannot handle in an accurate manner based on NISQ, which means that you need to minimize the computation cost. So from that perspective, combinations with mathematics and other technological fields would be also important. Thank you very much. Let me go to the next question. So I understand that your companies are now exploring how you can use the quantum technology, including certain proof of concepts. I understand that you are in that phase now. But when do you think quantum computing can be actually applied practically and in full scale to your business? What kind of time frame do you foresee? And what would be the key milestones in that journey? If you could share your thoughts on those questions, that would be appreciated. Ide-san, Yes, there is one key point, as mentioned by Ohba-san. Error tolerance is a key point. I thought 2030 will be the year, but according to Boston Consulting, it could be 2040, 10 years later than I expected. So I think that this error tolerance would be the key, and that would be a huge milestone for practically implementing quantum computing. Thank you. Sato-san, how about you? Well, it depends on the field that you want to apply quantum computing. The timeline would vary. Earlier, I mentioned that we have expectations for quantum computing in a factory production planning, materials development, and tire structural design. And one key point is, just like mentioned by the two panelists, FTQC is one big milestone, and beyond that, the timeline will vary from field to field. We have use cases where we have hopes. Then for those specific use cases, how many logical qubits do you need? That will be a key question or a criteria that defines timeline. When it comes to tire structural design, 40 to 50 logical qubits would suffice. We have estimated that way, very roughly speaking. However, we also need software which will run in that environment. Internally, we develop many tools on our own for the structural design. Therefore, we will also need a programming tools for quantum computing, which can be used in a similar way as we use the existing programming languages. Thank you. And it seems that we have some time, more time, so let me throw in some additional questions. 2030, you mentioned, or 2040. That is, I feel, far into the future, and I understand you create your roadmap backcasting from those milestones, 2030 or 40, but this time frame or timeline changes a lot. So when you have to adjust your timeline, how do you adjust? It doesn't have to be a solid framework, but if you have any approach to adjusting your timeline, could you share your practices? I think if you wait until it becomes practically available and implementable, then we will fall behind our competitors. We are in a preparation phase, so we have to familiarize ourselves with the quantum technology and quantum computing, and once a good quantum computer available, then we will have to be fully ready to implement them in our actual business. Sato-san, how about you? Thank you. And I agree. I fully agree with him. Earlier, I said that I thought 2030, but now people say 2040 is a change or difference of 10 years behind. But next year, we may say that it will be 5 years earlier. So, because of that uncertainty, it is very important to be part of the ecosystem now, not later. And by communicating with various people in the ecosystem, we will be able to flexibly adapt ourselves whenever that expected timeline changes. Thank you. What about you, Ms. Ohba? In the future, the quantum computers will become available around 2030 or 40, that's what people say. And at that time, I may have been retired already. However, still, we see to that time frame. For example, once we have certain many logical qubit quantum computers, then this is what we can do. We like to establish that kind of vision. However, with the current hardware constraints, we are doing this particular calculation, but with future level of quantum computers, this is the calculation we can do. Having that kind of vision ourselves is important. And also quantum computer is a very unique computers. So some people say that it is okay to start using and try using it once it becomes prevalent in the world, but that is not true. You have to start using it now, otherwise, and you have to familiarize yourself with quantum computing. Because of its uniqueness, it will be too late if you want to start using it once it becomes prevalent in the society.
Thank you very much. So the next question may overlap with the previous question. You have embarked upon the quantum computer for quite some time. So all of you are pioneer in the application of quantum computer for the industrial, the automotive application. So early involvement in quantum computing. What is the backdrop? What made you get involved in quantum computing so early? Would you please enlighten me on the motivation why you got involved so early? Most other companies are just gathering information, maybe. They have not even touched upon the actual machines. That's what I heard. So, what appears to be the most suitable, the starting point for industry or the company who have yet to start getting involved in the quantum computing? So I was involved in CAE, machine learning, mathematics. So if you go beyond that, and then what awaits beyond that should be the quantum. 5 years ago, that was atmosphere. The next year will be the quantum. So it's important for us to be early adopter in any technology. So that's what I got involved in quantum computing. Sato-san, okay, from my experience, my specialty is quantum chemical computation. In applying quantum chemical application for the tire material development, in terms of the accuracy of the computation, there are so many constraints that we should put up with. So that is the real life currently. So the quantum computing. So there are many constraints we have to put up with. So we need to overcome those constraints so that we will arrive at a better computation and to be useful for the business, for the company. That is the vision. That was the vision back in 2020. I'm not a quantum expert myself. So how could I get it started? What should I do? I had no idea where should I get started. But the Q-Park consortium, I got involved. So the Q-Park consortium was established, so I got involved. So 3 years passed since I got involved in Q-Park initiative with the consortium. By participating in the consortium, the better visibility of the technology and better, deeper understanding was acquired. So it was a good thing that I got involved in the Q-Park. So could be various consortium, not only the Q-Park. If you're interested, would you please try to participate and familiarize yourself with the activities at the consortium. So pick up a consortium that suits your corporate culture or the business culture of your company. That will be the good starting point. Ohba-san, please. Looking into the future, so the preparing yourself for the future vision, so that you need to get started early on. Back in 20, 30 years ago, I was the first principal calculation. That was the area I was involved in terms of the solid matter. There was no packaged tool that was available. New methodology that was presented in academia. I had to implement those newly academically announced methodology. So that phenomena is common for the quantum computing, various technologies and the tips and the differential, the equation, the quantum algorithm. They are announced in the various academic papers. So have establish access to those academic paper or the presentation and try to acquire those knowledge, and you should get involved and get involved in algorithm development so that you will build something that is made better. the quantum computer, when the physical hardware is ready, then you should be ready to apply such the soon to be made available physical quantum computer to your business, the issues. We still have some more time, so I'd like to ask some additional questions. You are taking initiatives in the quantum technology, quantum computing. What is the structure of the organization in each of your organization? What is the organization structure? For instance, quantum initiative to explore. Some people will consider the use case, and some other people, they understand the technology. And so this should be the hybrid of those capabilities. So what is the optimum team membership to advance the use case initiative? What is the optimum team membership of such a group? Ide-san, would you please start off? Yes, I understand. In terms of human resources, honestly speaking, manufacturing industry, there are not so many talents who are familiar with the IT, physics, and the information technology, and those talents could be applied to the quantum science. We are working with QC, where top-notch companies you should partner with, so that will accelerate or absorption or learning speed by having affinity with the top-ranking company in the industry. I have not been able to convince the management into the quantum initiative, so to be physically embark upon the quantum technology or to identify the use case, there is no such official organization within the company. Because in the quantum chemical computing, I'm interested in the development of the tire material. So how could quantum chemical, the computing should be positioned vis-a-vis the total management of the company? So I would like to organize the study session or the study group and invite those people who are interested. And what are the bottlenecks? What are the headaches? So I'd like to establish communication. Maybe the current bottlenecks, technical bottlenecks, could be the area where the quantum technology could be applied. So we try to consult the university professors and try to connect that opportunities with use cases in terms of the human resources availability. This is a great challenge. In my company, since we are tire rubber company, we have physical experts, quite a number of them. So the physics experts could be applied to the quantum initiatives. Ohba-san, please. Originally, in the material development, we used to run the mathematical, the computational simulation. Computer-aided engineering was applied for the structural engineering, utilizing classic computers. So that has been the culture backed up in the first place. So on the extension of such culture backdrop, the computation calculation as you explore those pursuits, there are certain problems we'd like to solve, but the current classic computers cannot address those problems. There are a number of challenges that is difficult to be addressed by the current classic computers. So the quantum computer should be able to provide the opportunities. So this is the expectation we're entertaining towards the quantum computer in a case of our organizations. The total organizations devoted to the quantum the computing. So we have established an organization, a group, the members, machine learning, and CAE, and the computation. Those are the backdrop of their the expertise. They have their own master equation that they are familiar with, and then try to apply that to the quantum computer, how quantum computers should be able to solve the equations that they are familiar with, they're trying to solve. The younger people, some younger people are quantum native. they can start the very lengthy calculation starting directly with the quantum approach. So the machine learning experts, they are exploring if they apply the quantum computing, what they could achieve the machine learning. So this is the direction. So we have expanded the view to the human resources development. So in the terms of human resources development for each of your company, what are the initiatives you are engaged in the developing the human resources development? Maybe you can work with university researchers or the startup companies and the learning from their wisdom or the state-of-the-art technology. What are the advantages of working with the external stakeholders to improve the human resources? What is the knowledge that is required? So that is startup companies that they have the plethora of required expertise that could accelerate the speed of the development. Thank you. Sato-san, please.
Well, we also engage with startups who are a group of experts because we are still in a phase where we cannot work on certain things hands-on, but contacting startups will give us more visibility into what quantum computing can do. And speaking about human resources, this is a future technology, so we will need new people. But being in this forum and speaking in front of you, I know here many people in the audience are from industry. However, if I speak in academic societies, for example, then that may attract more people to Bridgestone. Ohba-san, how about you? Well, learning about it on our own is very hard. So we engage with startups. Also, we join the consortiums such as Q-Park, where we can learn about quantum and improve our technology. Another way is joint research with universities, or in our case, QII or QCC. We use those actual quantum computers in consortium initiatives and joint projects where we can use the actual quantum computers. Thank you very much. You are all pioneers and you communicate and give out messages in various opportunities. So by speaking in this kind of engagement, does it help you to connect to people who are interested in quantum? No, that's a quite high hurdle. It seems that many people just shy away from the topic of quantum. So, right, in terms of scouting, that has not been done yet. But in our company, there are some young people who are interested in quantum computing, but it is still hard for them to work on quantum in addition to their day job. So we will need, I have only 8 years to go, but I understand that we have to start working to create an organization that will allow those young people to actually spend the time and work on quantum. Well, young people definitely are interested, but because they have their day job, main job, their hands are tied. And that is one obstacle for them to work or learn about quantum computing. But in a Toyota group, including AISIN, we have a voluntary group, a kind of club, where we have study sessions about quantum computing, and some young people are voluntarily joining those study groups and engaging with other group companies in Toyota Group. There is a good friendly competition between those volunteer members. So we have created a good culture about learning quantum technology. Thank you very much. And let me take a slightly different perspective. Just like Ohba-san, you have already a quantum organization, and in Mr. Sato's case, you are not there yet. So the situation or stage vary from company to company. But of course, I understand that you have a true passion for quantum and use quantum technology in your actual business. And to do so, you will need to persuade your management to actually start using quantum for your actual business. And could you share your experience in doing so? In our case, actually, our top management already interested in quantum, so we did not see any hurdle. What about you, Sato-san? In my case, I have not really sold the idea to the top management yet. And why? Because one big reason is that my lack of visibility about the top management's perspectives. Now, I used various words and phrases, and I'm trying what way of presenting would most resonate with the top management. Ohba-san, in my company, there was a top-down initiative, and the organization was created. So the top management have relatively good understanding about quantum technology, but to make it part of the actual business, we have to show what can be done, what can be achieved. Otherwise, it could be difficult to maintain this organization initiative in our organization. Thank you. And now let me go to my last question. So based on the current state of quantum technology, consortiums such as Q2B, what are the benefits or advantages of joining those consortiums such as Q2B? Ide-san, please, could you start off? Being able to know the latest quantum technology, that is what I expect from those consortiums. And we can also know new use cases which we never imagine ourselves. Thank you. There are three things, excuse me. First is we can broaden our knowledge. By joining a consortium, you will be exposed to brand new use cases which you did not expect. And the second benefit is deepening your understanding, because in consortium there are academic professors, students, or business experts, and they are open to answer our questions, and that helped me to deepen my understanding. And the third benefit, just as you mentioned earlier, we will have access to cutting-edge technologies and also use cases in other companies. In particular, Q2B allows you to have access to use cases of different industries, which is quite a rare opportunity. Last year, we had Q2B Tokyo, and I also went to Q2B Silicon Valley, which was very inspiring. And this time we have this 2-day session with many programs, and I'm really excited about it. Ohba-san, please. Through consortiums, I can come to know about many use cases and about how quantum computing can be used. And we can bring that back to our company and then showcase the potential of quantum computing to top management as well. And overall, networking is a great value. And through networking, we will be able to leverage technology, not just quantum, but peripheral technologies, so that we can leverage them for the good of the wider society. And another point is human resource development. Because when it comes to a new technology like quantum computing, it is very hard to develop a new talent on our own. But if we form a consortium And I see that those consortiums are also working to develop people in this field, and I have high hopes for that. Thank you very much, and it is good time. I'd like to conclude the panel discussion. And today I learned a lot from you. I believe that you also heard good informative comments from each other. And thank you very much for your participation.